So there's nothing from section 5.5 on the practice test, which means 5.5 doesn't occur on the test. Let me just go through these. You should feel a lot like the homework that you did. For question 1, it gives me a polynomial. Wants me to find an x-intercept, the multiplicity, figured out if the graph crosses or touches the x-axis. I'll start with that. To find the x-intercepts, we set the whole function equal to 0. And then we do the algebra to isolate the x's. This factor of x minus 4 squared, it's enough just to set the x minus 4 equal to 0 to get the x-intercept that it produces. And the factor of 2x plus 6, I'll set it equal to 0 as well. The factor of x minus 4, if I solve for it, I get x equal to 4. That's going to give me an x-intercept of 4, 0. The factor came from an exponent. The factor has an exponent of 2. So when I answer the multiplicity part, I'm going to say the multiplicity is 2, which is even. When I get to part 1b, the graph is going to touch the x-axis and not cross it at that point 4, 0, because the exponent that produced the x-intercept is 0. And you can see at the graph that I already have here, at the x-intercept of 2, 0, the graph doesn't cross the x-axis. It reflects off the x-axis. The other x-intercept I'll get is -3. I get that by minusing 6 from both sides and then dividing both sides by 2. The x-coordinate of the x-intercept is -3. Of course, when we write our x-intercepts, we write them as points. So I'm going to write it as -3, 0. And because the parentheses has an implied exponent of 1, I'm going to say the multiplicity is 1. More importantly, it's odd. So when I go to do part 1b, at that x-intercept, the graph is going to cross the x-axis. When the multiplicity is odd, the graph crosses the x-axis. When it's even, it touches the x-axis. So if I wanted to write here, for part A, I would do like the x-intercept is 4, 0, multiplicity is 2, which is even, -3, 0. The multiplicity is 1, which is odd. For part B, I'm going to say it crosses at -3, 0, and it touches at +4, 0. The next parts I'm going to get simultaneously is C and E. By taking this and expanding it without the exponent, and then multiplying the first term in each parentheses to figure out the maximum number of turning points and the end behavior, I need to do this algebra for the factored polynomials. So I'm going to multiply x times 2x. I'll leave the 2 out front, and I'll multiply x times x times x. And that whole thing multiplies out to be 2x cubed. That's going to give me the end behavior. The graph of this, if I get far enough away from the maximum and minimum points, is going to resemble that of 2x cubed. To figure out the maximum number of turning points, I just take that exponent and subtract 1, and I'll get a maximum of 2 turning points. Can't really fit it there, so just 2 is fine. Turning points, I guess I could squeeze it in. In terms of graphing, I want to make a graph, and so I need to plot the x-intercept of -3, 0. I need to plot the x-intercept of 2, 0, and I'm going to need to find this maximum point. And when I do the sketching a graph, I'm going to label the x-intercepts and the maximum and minimum point. This minimum point's already labeled. I don't need to relabel it. to find the maximum point, clear out anything I have in there, and go x minus 4 squared times 2x plus 6. And when I'm graphing these cubes or these polynomials, usually I make my x's go from -10 to 10, and I make my y start really large, and I progressively shrink them in until I get the maximum and minimum to be around the top and the bottom of the screen. And so this window it's actually even not that bad. I might live with that window. It doesn't make me feel good about my graph here. Y equals x minus 4 squared times 2x plus 6. I'm surprised. I'm skeptical on the graph that I have on here, but it doesn't need to be right. I can get the right answer from my graph as long as I enter the function right here. Y equals x minus 4 squared times 2x plus 6 looks right. That looks like a decent graph. Let me find this maximum point by hitting the second and the trace key, going down to option 4 that says maximum. Use my left arrow to get my cursor to the left, a little bit to the left of the maximum point, and then hit enter. Then use my right cursor to get my blinking cursor a little bit to the right of the maximum point, and then hit enter. And then get as close as I can to the maximum point and hit enter again. And I'll be darned. So what graph I have here is not so good. So let me make up on another sheet of paper a graph. As near as I can tell, my graph isn't really correct, but that's okay. I can fix this right now. So the graph that I should have drawn should definitely go through the x-intercept at 4, 0, touch the x-axis there. It should also go through the x-intercept at -3, 0, cross the x-axis there, but this turning point should be -0.67, 101.63. So I'm just going to estimate this really crudely. You don't need to be any more accurate than this. So -0.67, 101.63, rounded to 2 decimals. And then I'm just going to make a graph that looks like this. This is kind of what you should be doing in your homework. So even though I was trying to make my life easier, I failed. I don't know what function I graphed, but the graph should look more like this than it does the graph on the sheet. Not such a big deal. That's a hopefully correction. That's x minus 4 squared times 2x plus 6. This is the correct graph. This graph, wrong. I don't know what I entered wrong, but I apparently entered something wrong. This is what your graph should look like. On the test, your graph doesn't need to be any more precise than that. As long as it shows the x-intercepts properly and all the turning points, good enough. Problem 2 wants me to form a function that has x-intercepts of 2, 0 and -5, 0 with multiplicity 2 and passes through the point 3, 128. First, I'm going to set up my function that have the right x-intercepts. To have an x-intercept of 2, 0 with an assumed multiplicity of 1, I need a factor of x minus 2 with an implied exponent of 1. To have an x-intercept of -5, 0 with a multiplicity 2, I need a factor of x plus 2 with an exponent of 2. That will have the right multiplicity and the right x-intercepts, but there's little chance that it's going to go through the point 3, 128. So to make it go through the point 3, 128, I put a number to the left of the parentheses, and now I'm going to use the information to solve for this value. I'm going to plug 128 in on the left side of the equation, and on the right side of the equation, I'm going to plug in 3, which is the x-coordinate of the point, for both the x's, and then just do the algebra. This gives me 128 equals a times 1, and I'm going to write times 64 just to save a step, because that parentheses with the 3 plus 5 comes out to 8 squared, which is 64. So this is going to give me 128 equals 64a, and then divide by 64, divide by 64. You could use your calculator if you can't do that in your head. That gives me 2 equal to a, which means I need to change that a to 2, and then here's my answer. My answer has a 2 in front of a parentheses, and there's my x-intercept of 2. The factor is x minus 2. My x-intercept of negative 5 with multiplicity 2 from that factor of x plus 5 squared. Autofocus. I don't know if I could make it better, but I'm going to try. For C, I need to do synthetic division to factor this, and I'm going to start by graphing this function, trying to find a 0 in the y column of my table. So I'm going to graph the function 6x up arrow cubed minus 29x squared minus 17x plus 60. Do second in table and look for a 0. I see a 0 there at 5. So I'm going to write down my answer to part A is going to be x equal to 5. Parenthetically, I know that x minus 5 is going to be the factor that when I go to do part B to completely factor it, this x-intercept gives me a factor of x minus 5. Now I'm going to do my synthetic division. I'm going to use my backwards upside down division sign. The 5 that I got from my table, the 5 that had a 0 next to it in the y column, I put outside the bar, and then the coefficients of 6 minus 29 minus 17 and positive 60 go above the division bar. I bring down the 6, then I multiply 5 times 6 is 30. I add negative 29 plus 30 is positive 1. I multiply 5 times 1 is positive 5. I add negative 17 and 5 and get negative 12. I multiply 5 times negative 6 and get negative 60. Gives me my remainder of 0. This guy right here gives me 6x squared plus 1x minus 12. When I go to write my answer for part B, I need to get this factored. So let me factor this by trying to do grouping, but you don't have to use grouping. It's just what I teach. They're bottoms up factoring, and you could cite factor in your head. How I teach factoring, I would multiply the 6 and the negative 12, the A and the C in some sense, find numbers that multiply to negative 72, and add to that 1, which is the coefficient of the x squared term, of the x term, and that's going to be negative 8 and positive 9. If you multiply negative 8 and positive 9, you'll get negative 72. If you add negative 8 and positive 9, you'll get positive 1. So I'm going to rewrite this problem using the negative 8 and 9 in place of the x. Specifically, I'm going to make this 6x squared minus 8x plus 9x minus 12. And then from the 2 halves, I'm going to form 2 groups of 2 and pull out common factors. From the first pair, I'm going to pull out a common factor of 2x and be left with a 3x minus 4. From the second pair, I'm going to pull out a common factor of 3 and be left with another 3x minus 4. So this whole mess right there is going to factor into 3x minus 4 times 2x plus 3. That's really the hard part of this problem. Kind of have everything I need. Part B wants me to factor this, and the first step of synthetic division tells me that this guy factors into this x minus 5 times that 6x squared plus x minus 12. Now I know that I could factor, it says to factor completely, and I figured out how to factor this. So my answer to part B is going to be the complete factoring of this by changing this 6x squared plus x minus 12 into 3x minus 4 times 2x plus 3. So this is going to be my answer to 3b. 3c just wants me to solve the function equal to 0. To do that, this is equal to the function. I'll just set this equal to 0. So for 3c, I'm going to set x minus 5 times 3x minus 4 times 2x plus 3 equal to 0. The x minus 5 is going to give me an answer of 5 when I set it equal to 0. I could do that without algebra. For the 3x minus 4, to get the number for it, I would add 4 to both sides and then divide by 3 and get x equal to 4/3. And for the 2x plus 3, I would minus 3 from both sides and then divide by 2. And my answer to 3c is going to be x equal to positive 5, positive 4/3, and negative 3/2. Problem 4 asks me to create a function with degree 2 with lead coefficient 1. So my answer is going to have some sort of function notation. And the first term is going to be 1x squared because that's degree 2 lead coefficient of 1. Probably suppress the 1 and just write x squared. And I need to satisfy the conditions that it has zeros of positive 5i, so 0 of x equal positive 5i, and 0 of x equal negative 5i. I'm going to turn these into something that I could use for factoring. I'm going to set the x equal 5i to 0 and produce a factor of x minus 5i. I'm going to set the x equal negative 5i to 0 by adding 5i to both sides, and I'll get x equal positive x plus 5i equals 0. So now my function, I'm just going to multiply the factors I've created of x minus 5i and x plus 5i. I'll do that by foiling. My firsts are going to be x and x, which will be x squared. My outers are going to be x times 5i, and I might write that as plus 5xi. Might be 5ix, might be better, but it doesn't matter because it's going to cancel. My inners are minus 5i times x, that's minus 5xi. And my lasts are minus 5i times it's minus 5i times positive 5i. And that's going to be minus 25i squared. I multiply the 5 and negative 5 and get negative 25. I multiply the I and get I squared. These terms that I'm not really sure which order I really want to write them in cancel. And that's going to leave me with f of x equals x squared minus 25i squared. I squared can always be replaced with negative 1. So this is x squared minus 25 times negative 1. The double negative here I'm going to turn to a positive. And for an answer to number 4, the f of x equals 1x squared plus 25, or f of x equals x squared plus 25 is what I'm looking for. It's a polynomial. It has degree 2. The leading coefficient is 1. And if I put 5i or negative 5i in for x and simplified, I'd get 0. Just to show you, if I put 5i in for x and did something like parentheses 5 second I squared plus 25, that's putting 5i in for x. And when I do that, I get 0. That's what's required for something to be a 0. A couple of graphs to get through. So no holes, just simple, well, the simpler versions of these. And on the test, you don't need to graph, you just need to find the answers to all of these. So first I'm going to find the domain for 5a by setting the denominator equal to 0. When I set the denominator equal to 0, I get the equation of the vertical asymptote. There's a vertical asymptote at x equal negative 1. And I get the number that's needed for my domain. But to write the domain, I create a number line that has infinities on the edges and my negative 1 between the infinities. So the domain for this is going to be negative infinity to negative 1, union negative 1 to infinity. The vertical asymptote is going to be x equal to negative 1. Because when I go to part C, the highest exponent in the numerator is x to the first, which is equal to the highest exponent in the denominator, which is x to the first. To do part C, to find the equation of the horizontal asymptote, I write y equals, and I just divide the coefficient of the x to the first power term in the numerator and the coefficient of the x to the first power term in the denominator, and I get y equal to 6 for the equation of my horizontal asymptote. That's this line that's drawn here. That's my horizontal asymptote. It goes through y equal to 6. Part D wants me to find the x-intercepts. And for a fraction, it's enough just to set the numerator equal to 0 to find the x-intercepts, at least the x-coordinate of the x-intercept. I would add 12 and divide by 6. The x-coordinate of the x-intercept is 2. The y-coordinate is 0. And lastly, for 5e, and they can see it on my graph here, and again, you don't have to sketch these graphs, you just have to find all the points. To find the y-intercept, I plug 0 in for the x's. Probably could do this in your head. I'd get 6 times 0 minus 12 over 0 plus 1. The pieces with the zeros cancel out, and I get minus 12 over 1, which is minus 12. The y-coordinate of the y-intercept is negative 12. The y-intercept is the point 0, negative 12. And you can kind of see it written down here. You could graph it if you care to. You could set this on your calculator and just kind of copy what your calculator gives you, making sure your graph approaches the asymptotes and that it goes through the intercepts. But if all you got was parts A, B, C, D, and E, that's all you're going to need to do. Similarly, on the other question, that's a graphing question that has a slant asymptote, you only have to answer the questions. You don't need to produce this graph. So first I find the domain for part A. I find the domain by setting the denominator of the fraction equal to 0. That's going to give me x equal to 1. That's going to be the equation of my vertical asymptote. I'm going to get my domain by putting that 1 on the number line that has infinities on the edges, and then create the intervals that are implied. The intervals that are implied are the interval from negative infinity to 1 and the interval from 1 to infinity. C tells me it needs a slant asymptote. When the highest exponent in the numerator, in this case 2, is bigger than the highest exponent in the denominator, 1, you get a diagonal or a slant asymptote, and you have to do that by synthetic division. So for 6C, I'm going to do synthetic division. I'm going to change the sign of the minus 1 in the denominator, put that outside my synthetic division, and the coefficients of 1, 2, and minus 15 will go above that inverted division bar. I bring down the 1, then I multiply 1 times 1, I add 2 and 1, I multiply 1 times 3, I add negative 15 and 3. This gives me y equals 1x plus 3, remainder of negative 12. The equation of this slant asymptote is going to be y equal to x plus 3. If you care, this right here is the vertical asymptote at x equal to 1. This diagonal line that's drawn here is the slant asymptote that has an equation 1x plus 3, or just x plus 3. The last two things I need to find are the two x-intercepts. I have the graph already, so I know that they're 3, 0, and negative 5, 0, but you're not going to have the graph, so you're going to need to do the algebra. To do part 6D, to find the x-intercepts, I'm just going to set the numerator equal to 0. Because of the square, I need to factor it. And the numbers that are going to go in my parentheses are 5 and minus 3, because 5 times minus 3 is minus 15, and 5 plus negative 3 is 2. The algebra is going to give me the x-coordinates of the x-intercepts. After I factor it, I set the factors equal to 0. do the algebra to isolate the x, and that gives me the x coordinates of the x-intercepts, which are -5 and +3. I'll write my points out of those. And the y-intercept, I just plug in 0. So for 6e, I'm going to do f of 0 equals 2, and then I get 0 squared plus 2 times 0 minus 15 over 0 minus 1, just plugging 0 in for everything. All the pieces that are zeroed out, they turn into 0. I'm left with minus 15 over minus 1, and that's positive 15. The y-intercept, the y part of the y-intercept is going to be 15, and every y-intercept, the x part is 0. That's actually the entire test. I have no more of the review to do. So it's exactly these 6 problems, which means the problems will get pretty weighty. You know, here there's 1, 2, 3, 4, 5 parts. My guess is each part is going to be at least worth 3 points, possibly as many 4 points. I need to do what I can to get this test to work up to 100 points, and which means each one of these parts is going to be really important. And just perfect this. It's supposed to be an easy-ish test, I hope.